Hi, this screencast is on the basics of atomic structure, so the types of particles that make up the atom and how do we figure out how many of each of those particles are present in a specific type of atom. So let's start by taking a look at the basic structure of the atom. Recall from Unit 1 that the atom is the smallest particle of an element that retains the chemical properties of that element. So that means if you break the element down into anything smaller than the atom, it will not have the specific properties of the element. There are smaller parts that make up the atom, but those particles don't have the properties of that specific element. So the atom is made up of two basic parts. The first part is the nucleus, which is the center part of the atom. It's very small, and it is where we have the protons and the neutrons. So you see those particles here. We have protons and neutrons that are inside the nucleus of the atom. Surrounding the nucleus is this region of negatively charged particles, which are called electrons, and we call this region a lot of different names. It can be called the electron orbit, the electron cloud, just a lot of different names, but anytime you hear about this area outside of the nucleus, that is where the electrons are located in the atom. All of these particles, protons and neutrons and electrons, are collectively referred to as the subatomic particles of the atom. So how do we figure out the number of protons, neutrons, and electrons that are present in the atom? Well, we look at the periodic table and we use the atomic number and the atomic mass that is listed on the periodic table. Atoms of different elements have different atomic masses. The atomic number defines the atom and the element. So each element has its own unique atomic number, and that number indicates the number of protons in the atoms. So any atom that has 29 protons is going to be an atom of copper. Any atom that has 6 protons will be an atom of carbon. So that number identifies which element we're dealing with. The atomic number is always a whole number, as opposed to the atomic mass, which is the sum of the protons and the neutrons, and is presented with a decimal, but however will be used as a whole number in chemistry. So here in our example, we can see that the atomic number is listed at the top, and the atomic mass is listed at the bottom. We see that the atomic number is a whole number, whereas the atomic mass has a decimal. So for copper, we will have 29 protons, and because our number of protons is also equal to the number of electrons, which we see here, then we will also have 29 electrons in an atom of copper. And if we're looking for the mass, we know that we have 63.55 as our mass. That's the sum of our protons and neutrons. But when we use this number in chemistry, we're going to round it to 64. So again, if we look at the parts of the atom, the nucleus in the center contains the protons and the neutrons. The protons have a positive charge. The neutrons are neutral or have no charge, and both of these particles have mass. So I always remember this that protons, if I'm pro something, that's positive. Neutrons kind of sounds like neutral to me, so I remember that they have no charge. But both of these particles in the nucleus are the ones that contain the mass of the atom. The electrons orbit the nucleus, and they have a negative charge and no mass. So the way I remember this is electrons, if you were to be electrocuted, that would be a negative experience. So electrons have a negative charge. Please note that the number of protons and neutrons do not have to be equal in the atom. Okay, so we can have a different number of protons than neutrons, and that's perfectly okay. So let's look at some examples here. Here we have a model of carbon. This is a Bohr model, and carbon has an atomic number of 6, so that means I'm going to have 6 protons and 6 neutrons. In this example, the mass of carbon is 14, so this tells me that I am going to find my number of neutrons, I'm going to take my mass number of 14 and I'm going to subtract my number of protons, which is 6, and that gives me a total of 8 neutrons. So in the nucleus, I show my 6 protons and I show my 8 neutrons, and then I organize my electrons outside of the nucleus in the electron cloud or the electron shells. As another example, we have oxygen. Remember, oxygen has an atomic number of 8. It has a mass of 16. So since the atomic number is 8, that tells me I will have 8 protons and I will have 8 electrons. To find the number of neutrons, I take my mass number of 16 and I subtract my atomic number of 8, which gives me a total of 8 neutrons. So here in the nucleus, I show my 8 protons and my 8 neutrons. And then outside the nucleus in the energy levels or the energy shells or the orbits, I show my 8 electrons. So to practice, I would like for you to list the number of protons, neutrons, and electrons that are present in lithium, sulfur, and silver. And then I would like for you to draw a Bohr model of nitrogen and sodium, labeling each of the particles, so protons, neutrons, and electrons, and showing where they're located. Include these practice problems at the end of your notes, and show your notes to Mrs. Benke in the next class.